Hi, class. Today we're going to go ahead and talk about populations and natural resources. So, our key concept today is populations grow in predictable patterns. Populations grow in predictable patterns. Changes in a population size are determined by immigration, births, emigration, and deaths. The size of a population is always changing. There are four factors that affect the size of a population. We have immigration with an I, and that means when populations are coming into a community or when organisms are coming into a community. We have birth rate, which adds a positive impact on the population size. We have emigration with an E, meaning that organisms are leaving the community. And then we have death rates, which is negative, which decreases the population. So once again, immigration with an I means organisms are coming into. Immigration with an E means organisms are leaving. Okay, so all these factors affect the size of a population, whether it's going to increase in size, whether it's going to decrease in size, or whether it's going to stay the same. So population growth is based on available resources. So if we want a population to increase, there has to be enough resources in order for these populations to grow. Exponential growth is a rapid population increase due to an abundance of resources. So if you have unlimited resources, as we see here, we see that over time, population is going to continue to increase. And it's going to increase exponentially. So it almost looks like a J curve. Okay, so that means that these populations are going to grow out of control because they have unlimited food, water, shelter, and mates. Logistic growth, on the opposite hand, is due to a population facing limiting resources. So basically what happens is it reaches what's known as the carrying capacity, as we see here. So the carrying capacity is basically the amount of organisms that an area can hold. How much resources are available up until they reach this capacity. So this is known as logistic growth. So as this population starts to increase, they start running out of their resources. And that's when they reach this area here, which is the carrying capacity. So as it reaches, then we start seeing that the population is going to stable, and it may decrease if it runs out of resources. Okay, so once again, this is called logistic growth. Carrying capacity is the maximum number of individuals in a population that the environment can support. So a population crash is a dramatic decline in the size of a population over a short period of time. So if we look at this graph, we have the fish kill events versus rainfall in inches. And as we see here, this population starts to decrease. So fish are going to decrease based on the amount of rain. Okay, so based on the amount of rain. And as we see here, that's known as a population crash. So when it goes exponentially high all the way down to low. Okay, that means that possibly the carrying capacity is reached. Carrying capacity of the fish here would be about 17. Once it reaches this area, then we start seeing that the population starts to decrease. Right. Some ecological factors that limit population growth. So there are some items that can stop a population from growing. So a limiting factor is something that keeps the size of a population down. Limiting factor. So please make sure you know this term. So a limiting factor is something that keeps the size of a population down. When we have density-dependent limiting factors, those are affected by the number of individuals in a given area. Okay, density-dependent limiting factors. So as we see here, we have some wolves that are attacking, it looks like this deer in this instance. Okay, a limiting factor. All right. Density-dependent limiting factors are affected by the number of individuals in a given area. So some things that are density dependent would be predation, competition, and parasitism and disease. So what does that mean? That means that these populations are going to fluctuate. They're going to fluctuate. Okay, so density dependent limiting factors are affected by the number of individuals in that given area. So predation, so if there's going to be more predators, then that means that the prey population is going to decrease, as we see here. So notice I have my wolf population and my moose population. My moose population is going to grow out of control if there's going to be no prey. So population increases because they don't have any predators. Okay. Eventually, as we see here, when the wolf population increases, the moose population decreases. Why is that? Well, eventually these wolves here are going to start competing for food, and then their populations start to decrease as well. Okay, so density dependent would be predation, competition, parasitism, and disease. All right, in density independent limiting factors, these limit a population's growth regardless of the density. So density independent would be like unusual weather, natural disasters, and human activities. These here can stunt populations from growing. Okay, so we have no control over them. That's why they are known as density independent. They are independent. So we have like earthquakes, we have hurricanes, we have volcanic eruptions, fires, and tornadoes. Okay? All of these can limit a population. All right, here's a nice video for you guys to watch. It is on the life cycle of a plastic bottle, and it talks about how humans, such as us, have limited certain populations of organisms. Okay, and we want to see basically what happens to that plastic bottle. Our next item is Earth's resources. So in this section, for our key concept, as the human population grows, the demand for Earth's resources increases. So as the human population grows, the demand for Earth's resources increases. So let's look at some resources that we're talking about. So Earth's human population continues to grow. Our carrying capacity right now is unknown. So we have an unknown carrying capacity. And this is what we're projected at in the billions, right? So I believe right now on Earth, it was at 6.2 billion and rising. So this is where we're at right here. Notice by the years 2150, we're looking at close to 10 billion people. That's what the projection is. So as of right now, Earth's population, or human population, should I say, is growing exponentially. So we have unlimited food, water, resources. Now, technology has helped to increase Earth's carrying capacity. So we have gas-powered farm equipment and medical advances. If we think about times in the early 1900s, we know that Earth's population was pretty stagnant. Well, why was that? In the early 1900s, humans used to farm on their own. Okay, we didn't have these huge gas-powered farm equipment. So if there was a bad winter, wipe crops out. Okay, along with medical. So in the early, once again, 1900s, a lot of people died. Children died at an early age due to viruses and disease. As we start getting more medical advances and vaccines become available, we start seeing the population start to increase dramatically, as well as when the Industrial Revolution occurred. So when the Industrial Revolution occurred, we started seeing more of these larger farms, mass production of food. So food's available to everyone. We don't have to farm it anymore, so to speak. We can go to a market. It's mass produced for us. And that helps to increase populations. So the growing human population, though, does exert pressure on Earth's natural resources. So our non-renewable resources are used faster than they are formed. So non-renewable, these means that these cannot be replaced. And that would be like oil, natural gas, and coal. We have coal, oil, and our natural gas. Now, renewable resources cannot be used up or can replenish themselves over time. So that would be like wind, water, and sunlight. So anything that is renewable, they can't be all used up, okay? Or we can replenish themselves over time. So the growing use of non-renewable resources may lead to a crisis though. So our resources must be properly managed. So we don't want to have a population that is so high that then we end up using up all of our water. So there wouldn't be enough water that's continuously made. So we want to make sure that we start having more of our water conservation and so forth. Okay, so let's go ahead and look. These are our renewable resources. So we're starting to invest more into solar energy. Okay, our water as well as our wind. And then our non-renewable resources here, we have our oil, we have our limestone, we have phosphates as we've seen here. And that is our wind technology, which helps to make electricity for us. All right, please watch this video. It is a guide to the energy of the earth, gives you an idea of how we recycle and reuse energy. Now, effective management of Earth's resources will help meet the needs of the future. So we want to make sure that we're not using up all of our resources all at once. So we need to conserve. So Earth's resources must be used responsibly. Careless use of resources makes them unavailable for future generations. Easter Island is an example of irresponsible resource use. So there's this island which is known as Easter Island, and it was inhabited at one time. However, the humans that lived here at this time really did not take care of their resources as they should, and they ran out. So it does talk about here on this video what happened at Easter Island. I suggest once again, please go ahead and watch this video. And it talks about what can happen when humans are careless with our resources. What can happen when humans are careless with our resources. Right, an ecological footprint is the amount of land needed to support a person. So how much land is needed just to support you? The land must be able to produce and maintain enough food and water, shelter, energy, and waste, right? Food, water, shelter, energy, and waste. Okay. Here's another example of a video. This is called What is the Tragedy of the Commons? What is the Tragedy of the Commons? Please, once again, watch this video. It talks about our ecological footprint and what we need in order for us to survive. Now, there are several factors that can affect the size of the ecological footprint. So we're looking at the amount and efficiency of resources we use, as well as the amount of toxicity of waste that is produced. So notice here we have our population and our ecological footprint. So that's basically the damage that we're doing here on Earth. Okay, here's a population and here's the ecological footprint, what's needed in order for you to survive. So this is us, North America. Notice here that our population is one of the smallest, yet our ecological footprint is one of the largest. Okay, so we are a technologically advanced continent. However, with that being said, we also do use up a lot of resources. Then, as we would see here, Asia Pacific, their population has increased dramatically, but notice their ecological footprint here. It's very, very limited, meaning that they utilize and recycle a lot of their resources. All right, here's another video on the ecological footprint, which is explained. Hopefully this would help you a little more understanding. And then how long will human impacts last? So what do we do and what are some things that we do that impact our communities? And how long will those impacts last in our environment and how does it affect other organisms? All right, finally, our last section is on pollution, okay? So our key concept here is how pollution of Earth's freshwater supply threatens habitat and health. So the pollution of our Earth's fresh water supply threatens habitat and our health, which then affects populations. As you can see here, this is just a sludge of pollution inside of our water systems. So water pollution affects ecosystems. Pollutions can put entire freshwater ecosystems at risk, as we see here. Notice this area here has a high algal bloom. This algal bloom is probably caused from this sewer, from this pipe that's run off, okay, which makes the water inhabitable and not readily available for us to use or consume. There are certain indicator species that provide a sign of an ecosystem's health. So amphibians and our top predators. So if something's going on in the water systems, we have these indicator species, which basically shows signs. All right, here's another TED Ed video on the disappearing frogs, and talks about how we said like frogs are indicator species, and we look at what's going on in our water systems. All right, biomagnification causes accumulation of toxins in the food chain. Like we said, there's certain organisms that are indicators of what's going on in our food systems or in our water or pollution, okay? Pollutants can move up the food chain. How do pollutants move up the food chain? Well, predators eat contaminated prey. Pollution accumulates at each stage of the food chain. So we have our top consumers, including humans, are the most affected. So for example, let's look here. How does this accumulate up? So let's say that there is some toxins that were emitted in the water, okay? Those emissions then go to this phytoplankton. Phytoplankton are plant-like organisms that live inside of the ocean, okay? These zooplankton eat the phytoplankton, okay? So they eat a little bit more. So they eat a lot of phytoplankton, right? Okay, next we have the smelt. So this fish is going to eat a lot of these zooplanktons. Now notice as we go up, this parts per million starts to increase. Well, why is that? In order for this smelt to become full or eat, it needs to eat a lot of zooplankton. The more zooplankton it eats, the more it starts to ingest the toxin. Then we get to the lake trout. As we see here, the lake trout then eats the smelt. Same thing, it's going to eat a little bit more of these fish. As it eats more of the fish, the amount of toxin starts to increase at the higher rate. And then finally, we have the herring gull eggs. So how does it affect the herring or this type of seabird? Basically what happens is as this bird starts eating the trout, okay, the trout now notice that it has 4.83 parts per million amount of toxins inside of its tissue. So the herring eggs, what we were noticing is that the egg shells were very, very thin. Well, if the egg shells are not thick and they are very thin, every time the seagull would sit down on it, it would smash the eggs. If it smashes the eggs, there's no babies. So we started seeing rapid declines in these organisms. So we had to see why was this occurring? Why were the egg shells so thin? So scientists then did some research and found that it was bioaccumulation. Basically, the toxins that was being emitted in the water had a higher effect in the top organism. Here are two videos on biomagnification. Please watch these as you will be responsible for knowing this material. All right, folks, that is all for today. I hope you learned a little bit, and I hope you have a great day.